And this last one, number 3, goes over what we learned Monday. When you're multiplying radicals, you're going to multiply the numbers outside, completely separate from the numbers inside. And you always have 2 choices. You can simplify and then multiply, or you can multiply and then simplify. Albert, what did you do? Did you simplify first or multiply first? Okay, so Albert simplified first. So he might have done something like this. 7 root 2 times, I'm gonna factor tree up here so that we have room. Okay, 24. We can do, let's do the perfect square way. 4 times 6. 4 is a perfect square. You could stop there if you wanted, or you could keep going. So a 2 escapes. A 2 escapes and a 6 is left over. A 2 escapes and a 6 is left over. So this is really 6 root 6. So we simplified, and now we're going to multiply. 7 times 6, 42. Square root 2 times square root 6, you actually do multiply them. 2 times 6, 12. If you would have multiplied first and gotten 21 root 48, then you could have just factor treed the 48. Either way. Okay? Homework answers. There were only 12 problems that you needed to do. You only need to do 1 through 12. But some of these were pretty macho problems. So, do you have some I can work? Okay, number 8. Okay, 8 and 9. Anything else, guys? 8 and 9. Speak now or forever hold your peace. Okay, a couple of things that we learned on Monday. We had a checklist for making sure that our answers were completely simplified. So in that checklist, it said there can be no perfect squares left in the radicand. And that's kind of common knowledge. We learned that on day 1. No perfect squares left in the radicand. So factor tree it until you've got all primes. Then we learned no fractions in the radicand. Not allowed. And we learned no radicals in the denominator. So those are the 3 things you need to check to make sure your answers are ready to be submitted, to make sure your answers are perfectly perfect. Oh, that's a quote from Lala Loopsy because my girls watched that yesterday because we were home and bored. Oh my gosh. Anyways, so if we are looking at number 8, the key to these problems is to try to find shortcuts. If there's a shortcut, find it to make your life easier, because when you don't take the shortcuts, you have more potential to mess up. So I immediately see that 18 is in the radical and 3 is in the radical, and 18 is divisible by 3. 18 is divisible by 3. That's a shortcut. So I'm immediately going to rewrite this as that, because 18 is divisible by 3. What is 18 divided by 3? So you didn't have to rationalize the denominator, because we know if 2 numbers are both in the radicand, we are allowed to divide them. They are both in the radicand. We are allowed to divide them. So that problem was a lot easier than we thought. We didn't have to rationalize. Number 9. I'm going to do the opposite on this one. Instead of putting them together under the radical, I'm going to separate them because I spy something. Do you spy something? You should. Always be on the lookout for perfect squares. Always be on the lookout for perfect squares. Make it a game. Who can find the perfect square? Because when you find them, they make your life so much easier. Well, that's not done because we need to factor tree the 8, okay? But we're close. 8 is 2 root 2. Yeah. That's the real final answer. So, look for perfect squares. When you find them, use them to your advantage. Anything else on this homework before I move on? Any other thing I can work? Did y'all do it? Did y'all do these yesterday? When you had 24 hours of free time? Next thing we're going to do is the Mad Minute again. If you can promise not to cheat. I don't know how to check if you're going to cheat or not. Comment. Okay, old news. Pythagorean theorem. A and B have to be the legs of a right triangle. So notice we are only going to use this for right triangles. And C is, of course, the hypotenuse. You can recognize C by drawing an arrow away from the right angle, or you can just find the longest side if you happen to know all the sides. Pythagorean triples. These are sets of whole numbers that satisfy a squared plus b squared equals c squared. So you don't have to these are kind of like perfect squares. If you memorize them, they'll make your life easier. If you don't memorize them, that's fine. Some problems will just take you longer to do. So 3, 4, 5 is called a Pythagorean triple because 3 squared plus 4 squared equals 5 squared. But the cool thing is that you can take these Pythagorean triples and you can multiply them by a constant, and they're still a Pythagorean triple. So let's multiply 3, 4, 5 by 2. 3, 4, 5. You get 6, 8, 10. That's a Pythagorean triple. 6 squared plus 8 squared is 100. It's 10 squared. So if you memorize these, you're just going to solve some problems a little bit easier. Let's triple 3, 4, 5 and find another Pythagorean triple. 3 times 3. 4 times 3. 5 times 3. So 9, 12, 15 is a Pythagorean triple. 9 squared plus 12 squared equals 15 squared. Anyways, good to know. Google it. Like when I'm making up problems and I want the answer to be pretty, I Google Pythagorean triple and I get this long list of Pythagorean triples and I just pick the one that looks like fun to use. So that's how I make up problems when I want the answers to be pretty. All right. Why are we doing Pythagorean theorem again? You're like, we did this last semester, we did this in middle school. I mean, come on. Well, the reason we're doing it again is that we're doing it kind of in a new light because now we know about radicals and we know how to simplify a radical. So we don't need to get a decimal answer anymore. We can get a simplified radical answer. So that's why we're doing Pythagorean theorem again. Because when you square things and you square root things, you're dealing with radicals naturally, and we're in our radical unit. So, anyways, yes, you are in middle school. Okay. Ready? Find the value of x and leave in simplified radical form. So we are going to follow the formula a squared plus b squared equals c squared. 25 plus. Now we know what the square root of 3 squared is. It was in the warm-up. The square root of 3 squared, they cancel, it's 3. And some of you already have the answer and you're telling me I'm taking too long. Okay, so we've got 28 equals x squared, and we are going to square root it because that is the opposite of squaring. And then we will factor tree it, or you can find the perfect squares in 28. 28. 7 and 4, very good. 4 is a perfect square. 2 root 7. So the answer to the problem is 2 root 7. Sometimes I might tell you to leave it in decimal form, and sometimes I might tell you to leave it in simplified radical form. That is the simplified radical form. 2 root 7. 2 square root 7. Try this one. Much wow, much Austin. Oh my gosh. Is it a Pythagorean triple? So, Pythagorean theorem says to do this. And then you subtract 12 from both sides. But honestly, guys, do you do this too? When I'm looking for a leg, I subtract, and when I'm looking for the hypotenuse, I add. I don't do that first step. That's up to you. If you want to write that first step, that's how you do it. But you have to move the 12 squared over, so you're going to end up subtracting, which is how I start it. So 25 squared minus 12 squared. No, it's not, Helaman. It's not a Pythagorean triple. All right, so 25 squared minus 12 squared. 481. So now we need to find things that go into 481. What do you want to use, guys? Have you found anything? Okay, let me show you a trick if you're stuck. I showed you how to find a square root in the calculator, and it's to do that. But let's say we want to factor tree it ourselves. Okay, sorry. Oh my goodness. Go away. Go away. Go away. There we go. So, if you want to see what are the products of 481? What numbers are divisible? What numbers 481 divisible by? Sorry. What numbers go into 481? You go to y equals and you do 481 divided by x because I want to know what divides into it. So then I go to my table. So this is a good thing to do when your number's large and you divided it by 2, 3, 4, 5, and you're not getting any results. So, notice, it's not divisible by 3, it's not divisible by 4, 5, 6, 7, 8, 9, not divisible by, and I found a winner. Look, it's divisible by 13. So 13 times 37 is 481. We're spending a lot of time talking about this, and it doesn't really matter because those are both prime. So 481 is 13 times 37. Prime, prime. So this is actually, believe it or not, the final answer. There are no perfect squares in 481. So the answer to this problem is x equals square root of 481. I know it's ugly. Can we move on? Is that okay? It cannot be simplified. Okay? Okay. Next one. Those are tick marks. They're hard to see. It is isosceles. Excuse me. Do y'all see the Pythagorean triple? Because if you've memorized your triples, you could solve this one in 2 seconds. 2 seconds. 6, 8, 10. 6, 8, 10. It's one of your triples. If you didn't remember your triple, that's okay, because you could do 10 squared minus 8 squared. You'll get 36. You'll take the square root of 36, and you'll get 6. Since it's isosceles, we know that the altitude is also a median. We know it. So if that's 6, that's 6, and y'all are totally right. You're already typing it in the chat. X is 12. Pythagorean triples are your friend. Get to know them. I spy another triple. Do you spy one? 3, 4, 5, 9, 12, 15. But like I said, it's okay if you don't know it. 9, 12, 15 is another triple because it's 3, 4, 5 times 3. So if you know your triple, you're like, wow, I got this. I got this. I got this. And so 24, 34. Man, that was an easy problem. We didn't even do Pythagorean theorem because we knew our triple. But if you didn't know your triple, you would have done this. 15 squared minus 9 squared, and you would have come up with 12 on your own, okay? That looks like fun. No. Helaman's already done? A squared plus B squared equals, I'll call it C. C squared. Cancel. Cancel. A squared plus B squared. Wow! That's nice! Phew! Turned out pretty. It got uglier and then it got pretty. It happens all the time, Helaman. Don't feel bad. Are we okay with this problem? That was kind of cool. That was fun. Moral of the story. When you square a radical, it cancels out. The squared and the square root are inverse operations, so they cancel. And you're left with the radicand. All right, draw a picture, please. I'm going to cheat when I draw my picture. Although that doesn't look like a very good square. We'll pretend it is. I'll give you a minute because I want you to figure it out yourself. This actually leads perfectly into Friday's lesson. Used to be like today's lesson, but now it's Friday's. It's okay. If you're still solving it, don't look at the board, but I'm going to just keep the class moving. Are we doing okay so far? I'm showing every single step. You don't have to do this. I'm kind of being excessive. That can't be my answer. because I have a radical in the denominator. So I need to rationalize, which is what we learned on Monday. So there's my final answer. 13 root 2 over 2. Is that what you got? Good job, Helaman. Okay, Taha, but it's a square. So that would be awesome if it was a rectangle. You could get 5 and 12, but it's a square. Yeah. So I had to name both of my sides the same exact name, x and x. I couldn't name it x and y because they have to be the same length because it's a square. Okay. We're just going to do more radical practice. The lesson is over, and now we're going to do more radical practice. Just getting good with adding, subtracting, multiplying, and dividing our radicals. Let's do races. Who can type it first? I'll keep score. Go. Six root 2. Yeji's first. That is the answer. If you need me to work one of these, you need to let me know. Was Yeji first? I'm trying to go back up and I can't see. Yeah, Yeji was first. Oh, the old enter button glitched excuse. Okay, next one. Who's going to be first? Wow, Albert. Albert got that one. Did you do it the perfect square way? Like this is 75 square root of 25. That's 2. Oops, sorry. Remember, that's the perfect square way. You don't have to do a factor tree if you know already a perfect square that goes into your number. That was definitely Albert, right? I think that was Albert. Oh, ho, ho, ho. They're so funny. Oh, yeah. Sorry. Yeah, that was good. Woo! Took me a second. Good job. George won that one. George won that one. How'd you solve it, George? Did you multiply and then simplify, or did you simplify and then multiply? What did you do first? Okay, so let's multiply. 6 times 2, 12. 3 times 12, 36. You've got to keep your eye open for perfect squares. I cannot say that enough. 36 is a perfect square. The square root of 36 is 6. You don't even factor tree it. Don't do it. Don't factor tree it. Memorize it. The square root of 36 is 6. So it's just 12 times 6, which is 72. Perfect squares. You can probably all do this in your head. It's just who can type it first. Helaman won that one. Yep. On the quiz, should I make you put that in parentheses? I still haven't decided how to type it on the quiz. Because that technically is wrong. Because you're not using parentheses, so that's saying the 2 divided by 2. I don't know. I don't know how we're going to do it on the quiz. But either way, you rationalize this. So your numerator is 3 root 2, and then square root 2 times square root 2 is 2, and you're actually done. I think I'm going to have to make it multiple choice. I don't know. Albert, almost. Hussein, you got it. No one has gotten one twice. We've got Yeji, Albert, George, Helaman, and Hussein. Erg. All right, so 84. You're just factor treeing 84. It's 4 times 21. 21, you don't find any pairs in there, so you just put that guy right back in. Okay? Okay, got it. Hussein! Oh, 2 for Hussein. It is 2 root 3 over 7. Square root of 49 is 7. The square root of 12 is 2 root 3. So it's 2 root 3 over 7. Are we okay? Okay. Next one. Who's going to get it? Who's going to get it? Who's going to get it? George! George got it! George and Hussein are tied. 48 is divisible by 3. Don't give up, Brandon. You can do it. Okay. Stop it, Austin. Math is not about being quick. We're doing this for fun. It's about getting it right. It's not about being first. It's about being right. Okay, got it. Minjung! Yay! Good job, girl. 1/2. So the square root of 27 is 3 root 3. You factor tree, or, well, you could have divided. There's all different routes. Let's do another route. You could have said 1/6, or how about this? Could have just divided, 27 divided by 3. But y'all probably got confused about where to put the 6. There's a few ways to do this one. Either way, 27 is divisible by 3, so you're allowed to divide them. But I factor treed the 27 in my head real quick, and then I canceled out the 3's, and then I got 1/2. Either way, you'll end up at 1/2, obviously. Different ways to do that. You can divide them, or you can simplify and reduce. All right, that's all I have today. You've got a Pythagorean Theorem worksheet, and you've got a quiz tomorrow and a quiz on Friday. We wouldn't have had enough time for the quiz today anyways, Yeji. George and Hussein tied for winning.